Awesome. Cool. So just a brief intro about myself before we get started. My name is Raj. I'm a technical account manager with AWS. Been with AWS for about 3 years now. Currently I'm working on my ML specialization, specifically focusing on SageMaker. And I'm based out of New York City. So this session is going to be a theoretical session. There's not going to be much of a hands-on. Later in the day, you'll have a lot of hands-on in terms of deep dive into SageMaker. But this session will help you in that session. So I'll try to cover as much details as possible in terms of all the theory that you need to know with regards to SageMaker. Even though we talk about machine learning, AI stuff, this session, the next 1 hour, is going to be complete focus on SageMaker. And I'll try to make this session as interactive as possible in terms of sharing with you how was my learning experience, rather than talking about customer cases, because I believe that the later sessions in the day, you will hear more about customer cases, what we talk to customers. But this session, I'll try to focus it in such a way that this is going to help you, not just for today, but rather for you to go back and refresh. And as and when we talk about each topics in the session, I'll give you some pointers or some perks. Feel free to take some notes. And all these pointers are going to be on the websites. So you can have your browser open and then bookmark these sites, which you can refer later. And one quick thought before we get started, with regards to machine learning, right? Machine learning and AI as a whole, it's a topic of interest for business across the globe. And even though it's a topic of interest, it's not very mature at this stage. At this stage, it's more experimentation. It's a lot of literature that is available that you can read. The reason why I say that is because you got to experiment and try to figure out what the solution that will fit your use case. Because a generalized solution may not be the right solution for your use case. So keep that in your mind as you move forward in case of however you're approaching a problem to be solved with a machine learning model or understanding a use case. Just keep it on back of your mind that this needs to be a custom solution that you're trying to build. Take all this experience, yes, it's going to help you, like all the pointers that I'm going to share, but the solution that you will come up with is going to be particular to your use case, and that may not be available yet. Yep, good. And then one more pointer that I want to share is that through the session, not just for this session, through the session today, for all these sections, I would recommend you to follow an approach where you take a concept and then go backwards from that. That is the most easiest way to get started with machine learning, if you're starting with machine learning. Like say, we talk about automatic model tuning, for example, right? Take automatic model tuning and then read about that. When you're reading automatic model tuning, you will hear some jargon words like Bayesian search, random search, right? You may not know that in first tense. That's absolutely fine. Take that terminology, do a search on that, and then you will get to know what that is all about. And then take that terminology and then go backwards from that. That will help you in the learning process. The reason why I wanted to share that is that's something one of my mentors shared internally at Amazon, which worked out well for me. I'm just sharing that. Try that if that would work for you. Cool. Before we get into the first section of today's session, quick show of hands, just 2 top-level questions. How many of you have prior hands-on experience with SageMaker? 3, good. How many of you have prior experience in general with machine learning concepts? Fair enough. So the reason why I asked that is that should I go forward with SageMaker straight away, or should I set the stage for machine learning, artificial intelligence, and so on? Cool. So this is the complete portfolio of machine learning services that Amazon offers as of today. At the top layer, what you see is the AI services, which doesn't require any expertise on machine learning. It's a quick plug-and-play service that you can use and integrate with your application. What I mean by that is, let's say you have a business application that is exposed to the customers, and then you want to do image recognition, and you could use the recognition service from AWS. Yep. And for that, you don't need to know how to train a model, because these are all pre-trained model that is readily available for you to just go ahead and interface through an API. And these APIs will directly interface with your applications. Similarly, if you're going to play with speech, like turning text to speech or turning speech to text, use one of these services, Poly or Transcribe accordingly. And then when you are going to work with language, translate, comprehend. And then if you want to integrate a chat bot, then Lex is available. Again, the machine learning expertise that is required at this layer on the top is very less. You can straight away go ahead and plug in all these services directly to your applications. And then you also have forecasting service and recommendation service. These services are the services that Amazon.com uses, the same technology that Amazon.com uses, and it is available for customers to go ahead and use. And there are also a few more services that got introduced during reInvent, which in the latest section, if we have time, the last 5-10 minutes, I'll try to cover up what's new with SageMaker in that section. And then there we'll talk about what other plug-and-play services you got in that section. The middle stack that you see here is the ML services. And this is going to be the core component for today's session, the first session that we talk about, which is Amazon SageMaker. SageMaker is a fully managed machine learning service that helps developers and data scientists to quickly get started with machine learning service, and that also helps to build, train, and deploy machine learning models pretty quickly. You can get started pretty quickly with SageMaker. And then initially we started as build, train, and deploy, but now you could use SageMaker to also do debug services. And if you are looking for a complete developer environment, you could also use SageMaker's Studio, which is an IDE. That's a new service that we launched, which you can use that for complete integration for experimental purposes. And then the bottommost layer that you see here are the ML framework and infrastructure. That is the most complex layer. That is, again, available from a flexibility standpoint in terms of for people who want to experiment more and they want to come up with a service on their own, right? So if you see from top to bottom, the complexity increases. Like in terms of the knowledge that is required to operate at each layer, as well as the expertise that is required, the complexity increases. And then as you move up the stack, the complexity decreases. So there are certain services that are available on the top layer, which you can quickly plug and play. You can use those services. And then if you want to build your own models, then you use SageMaker. And then if you want to come up with your own service where you need more flexibility, then we have a wide range of supported frameworks such as MXNet, PyTorch, TensorFlow, and then the interfaces that you can interact with, like Gluon, Keras. And then from an infrastructure standpoint, that's going to be standard, right? Whatever that you want to develop in terms of the different types of EC2 instances, the EBS volumes, the portfolio of VPCs in terms of networking, all of these infrastructure is available for you. So the freedom is there in terms of what you want to do. Again, it all depends on the use case that you got and at which complexity layer that you want to engage with the AWS services. Yep. So let's agree one thing, that ML was complicated, right? And it is still complicated in terms of what are the different things that you need to get started and what are the different processes that you need to follow to go from start to finish. And when we say start to finish, what are we talking about? You're going to start with a problem statement, a business situation or a business problem that you have, and you're going to end up with a prediction. All machine learning models will end up with an inference or a prediction. You want to predict something, right? That could be anything. Maybe a set of players running in a football field, and then you want to know what the score is going to be. You want to predict, is this going to turn out to be a success or a failure? Right? Binary classification, multi-class classification. At the end of the day, it's going to start with a problem, and then it's going to finish with a prediction. Now, starting with the problem and then ending with a prediction here, there's a lot of steps that you got to follow in terms of taking the data, cleansing the data, and then making sure that data is readily available for the model, and then you create the model, and before you create the model, you need to know which model should I choose, or which algorithm should I choose to build that model. And then finally, once you build the model, then comes the problem in terms of, hey, what are all the parameters that I need to choose for the training? And how do I tune my hyperparameters? And then finally, once you finish that, you get into the different problem altogether in terms of how do I take it to production? Because all of this, whatever you did in terms of testing, creating a model, deploying a model, this is all in an experimental purpose. And once you're done with it, you take the model to production, there is a new problem altogether in terms of how do I handle it with scale? You have like 100 users today. Tomorrow, those 100 users could be 10,000 users, right? So how do I handle that? And today I make predictions for like n number of parameters, and tomorrow that parameters could be n into 100. Right? So how do I scale with those parameters? Today I have, with the range of users, my data is also going to grow. And how do I make sure my model is not overfitting or underfitting, right? So all these complexity comes in. And then on top of all of this, who's going to manage this infrastructure, right? I want to patch this infrastructure, make sure it's secured. I need to make sure that there are no issues with the infrastructure when it comes to high availability, scalability, right? So all of these things comes in. And to address this problem, right, to address all of these complexities that we spoke about, we came up with SageMaker. SageMaker primarily is to address all these challenges in terms of making sure you are easily able to get in and get started with your problem, come up with a solution, and then deploy it into production. So these are the different phases that we spoke about, right? So from a collection of data and labeling the data, we have ground truth. We'll talk about that as we move forward. And then notebook instances, that is going to be your interface into your machine learning models. How do I interact with machine learning notebook instances? These are fully managed Jupyter notebook instances. We'll talk about that a little later, but that section typically talks about how do you clean, format, and transform the data, develop a model, and then how do you train the model. And then when it comes to training, you need to make sure that you quickly take the model that you build and then train the model, as well as you got to evaluate, is the model performing to the level or the optimal level of what my expectations are? Is the results that I'm getting, are they accurate? Or should I need to tune it further? And then once you do that, then comes the inference. The inference is nothing but your prediction. You got to infer something out of the problem, right? So that is the final stage. And for getting the inferences, you got to make sure you deploy the model into production, and then you're able to scale and manage the model. And that is handled by SageMaker inferences. That's again to deploy a model into production and then handle it at scale. So we spoke about certain aspects of SageMaker which addresses each problem, right? We're going to go through each and every aspect of SageMaker. How does it address it? Whatever that was covered in the previous slide, we're going to go through each of those sections. First, let's talk about ground truth. Now, you have data, and then that data needs to be cleansed, and it should be in the right format for SageMaker to accept, right? So that only then you will be able to derive the models more accurately. And the data cleansing, data prepping, all of this process is a bit complicated. Now, before we step further, there are broadly two types of algorithms, right? Which are supervised and unsupervised algorithms. We all good with supervised, unsupervised algorithms? Or you're good, right? So just in a nutshell, supervised algorithms are the ones which are already prepared, and then the data already has some kind of a label to it. So that these are, I'm helping the algorithm in terms of supervising it and providing some assistance. And that assistance is nothing but I'm labeling the data. Unsupervised algorithms, on the other hand, the data is not labeled, and the machine learning model should have to adapt by itself, right? Most of the algorithms that are used today are supervised algorithms. Now, if you're going to take a supervised algorithm and then you're going to feed the labeled data, you need to have the data label. And there are a lot of data sources for you to experiment which is labeled. But if you're going to come up with your own machine learning problem, then probably you may have to label the data. Let's say you have thousands of pictures of birds, right? And then you have to identify bird versus a tree in that picture. I'm just taking a very simple use case, but it could be anything. Football players running in a field, and then you got to make sure what move he's going to make, and then you need to make sure that you identify which player. And how will a machine understand player X versus player Y? That's through labeling. I need to label words and tell machine that if you see the pixels in this order, this is player A. If you see the pixels in the other order, it's player Y, right? So for that, you need to make sure you have a proper labeling process. And today, the challenge that we have is that even though we have workforces to label, there's no set process that different organizations have to engage them, like the right tools for people to be engaged and collaborate. And ground truth is the right tool for that. Now, what happens in ground truth is that you take the data, and you put the data in S3. And then once the raw data is in S3, when I say data, these are the pictures that we were talking about. And then you start the process of labeling, where initially you will identify, hey, these are the things that I want to label. And you are going to basically give an instruction that, hey, this is what I want as an output. And then based on that, first humans begin labeling. Right? You have human workforce beginning labeling. And then, okay, humans can do labeling without ground truth, right? Now, what's the big differentiation? At some point, the machine learning process kickstarts, and then it starts learning. And how will it start learning? Based on the previous data that humans have started. So let's say you have thousands of images, and maybe at around 100, 200 images, the machine learning process starts labeling. Now, when the active learning model within ground truth starts labeling, there could be a case where there is an anomaly where the machine learning model is not 100% confident how to label. So in that case, it will pass it back to the human labelers asking for assistance. Hey, I'm not sure. This is like, I'm only 30% confident that this is a bird. Can you label that for me? And then it goes as a cycle. And based on the data that is fed in, it will again start learning from that. You don't have to know about this, but this is more of a knowledge from your perspective. But as an end user, what should I know? As an organization, what I should know is that you need to have some kind of human labelers, right? Those labelers could be private workforce. If your data is going to be confidential, then you will use your own private workforce. You come up with a team who will do that first initial stop. Or if you think that I cannot come up with private workforce, then probably I need some assistance there. You could use Mechanical Turk. Mechanical Turk has been there for a long time with Amazon. These are human workforces that you can use to get accomplished a particular task. Or there are marketplace providers, third-party providers, who also do the labeling for you. So there are three options right now for you. Use your private workforce, use Mechanical Turk, or you could go to marketplace. This is, again, flexibility. There's no one-stop shop answer for this. It's more about what do you want to do, right? But the flexibility is there. Now, this is going to be the interface for a labeler. If I'm a labeler, let's say I'm a private workforce for my organization, and the organization sends me the data to label, right? This is a very simple example, but it could get as complex as it could be. I'm going to identify what is there in the picture, and I want to draw the bounding box. That's basically my task. So I say, okay, I found this to be a dog, and then here is my bounding box. And then the output of this, because we started with the data in S3 bucket, and then this is ground truth, and the output again is going to S3 bucket. Now, the output is going to have a augmented manifest file. Now, what's an augmented manifest file? It's a simple manifest file. Manifest file is nothing but it contains the instructions of what to label. Augmented manifest is, because it is coming from an automated process of labeling, it is going to have coordinates. Like, hey, this is the coordinate of the bounding box where the image is present, and then what the image is all about, and then it will also talk about the height, width, and some of the properties of the image. And also say, hey, this is an image of a cat, or a dog, or an X, or a Y, or a Z. Yep. So this is going to be the output. I'm trying to keep it at a high level so that we cover as much details. And then once we are done with the session, I'll open it up for any questions that you might have so that you can let me know. And if you have any questions, please make a note of it. The objective is to make sure I cover all the content and then open it up for any questions. Cool. As I said, we won't spend a lot of time on this slide. We covered this already. There are 3 different options for you to use the workforce, right? This is primarily to cover who are all the marketplace providers that are available for you to engage on labeling. Yep. Notebook instances. So how many of you are familiar with Jupyter notebooks? Cool. So in that case, there is nothing new here. It is pretty much the same Jupyter notebook what you're aware of, but the only difference is that it's a fully managed Jupyter notebook instance that is available on SageMaker. Some questions might come in, like, why should I use it on SageMaker? Can I do it on my laptop, the notebook instances? Absolutely, you could do that. That's in fact one of the advantages of using SageMaker, right? You deploy your notebook instance on your laptop, come up with a model, and that model is going to be completely portable to get into SageMaker. So you don't have to worry about it. So you can create your model that is designing the model on your laptop, portable into SageMaker, and then where you deploy it, and then you take it into production as well. It's completely up to you. But again, if you want to have a complete integrated environment where you don't want each developer to use their own laptop, you could absolutely use notebook instances. Because today, with a new feature of within the studio on the experimentation part, you can share notebook instances. That's a recent feature that we announced during the reInvent. If you want multiple developers to coordinate, you could do that as well. That was one of the most asked feature requests, and then you have that available as of today. So as I said, these are fully managed Jupyter Notebook instances. And then typically in your Jupyter Notebook, you also have 2 options. One is the standard Jupyter Notebook, or you could get into the Jupyter Labs. And then from a kernel perspective, as you see on the right side when you open the notebook instance, there are several kernels that are supported here. By default, you would get some of the kernels, and you could absolutely switch to whatever kernel is of your choice. And then there are also options to import libraries as similar to how you would do it with your standard Jupyter notebook instances. The good thing about it is that since most of the code today lives in JIT, it has a direct integration with JIT repository. So you could do a direct integration to JIT. And then one of the most advantages of using notebook instances in SageMaker is that you have a lot of sample notebook instances to get started. If I'm not wrong, it should be 200 plus notebook instances that are available as of today. When you log into, I'll try to log into the notebook instance and show you. There'll be a separate tab of examples, SageMaker examples, where if you go and click on that, you will get a lot of notebook instances that you can quickly get started. Again, these notebook instances are again completely customizable. You don't have to start from scratch. You could take an example and then customize it if that is what you want to do. Or if you want to start from scratch, that's up to you. Yep. Now, training. Once you have come up with your model, you need to train the model. So that's the next step eventually, right? So that the model is able to make the right predictions out of. Before you get into production, you need to train the model, and then you need to evaluate if it is giving the right results for you or not. So from a training perspective, there are different options for you to get started. Again, as I said, you could start it from your laptop itself. There are several APIs through which you can interact with SageMaker. And another good thing is that from the console directly, you could log in into SageMaker, start your training job. And the third option is, from your notebook instance, you can initiate the training. So you have different interfaces how you can initiate the training. And when you're going to get started with the training, if this is an example of how do you do the training from your notebook instance. All you have to do is, in this case, we are calling the estimator, where the estimator is basically a function, where we are saying, hey, I need one instance. What instance? Maybe a C4 family, X large instance. That is what I choose to be the optimal one, but that could be different for you. You choose the instance, say how many instances you want. You could start with 1 or 2 and then see from an experimentation perspective how the results are, and then you can upscale it. This is not set in stone. You could change it as and when you require. And then you say, hey, I need to create a batch size of 200 and then initiate the training. And this would be one of the components within the notebook instance just after you put your data into SageMaker. Because the first step is that you need to define your data, right? So just above this, typically in notebook instances, you will say, hey, this is my S3 bucket where the data resides. And then here you call, I need X number of instances, this particular type of instance, and then this is where the data resides, and then train the model accordingly. Now, when you get started with training, there are multiple options that are available for you to get started. The first option for you to get started is, as I said earlier, there are several built-in algorithms with SageMaker. You can get started with that. The second option is you can come up with your own custom script that you can use to train within the SageMaker instance. And then the third option is you could bring your own algorithm. Now, you could ask me, hey, what is the difference between the algorithm that SageMaker offers, which is a standard algorithm? These are, let's take an example, linear learner, right? It is the standard linear learner algorithm, but it is optimized. Optimized for what? Optimized for how does it interact with SageMaker, optimized for running within AWS cloud, and so on. Is that clear? It's the standard implementation, but it is pretty much optimized in two. If you ask me, what are the two ways it is optimized? One, from a scientific perspective, as well as from an implementation perspective, like how it is going to interact with the SageMaker instance, as well as how is it going to interact with the AWS ecosystem. When you ask me what is an ecosystem, if you're going to have your data reside in S3, that builds your ecosystem. So you have the data coming from S3, and then SageMaker is going to train the model, get the data from there, and then it's going to output the model into another S3 bucket, or so on. So that is optimized, right? If you're going to take a standard implementation from outside, then probably you may not be able to integrate it well with S3. Yep. For example, I'm saying that could be anything else. And then finally, the other option that you have is Amazon Marketplace. And this is, it's not just for SageMaker, right? If you look at AWS services as a whole, you will see these 4 layers. One, you could use the services that AWS offers. There is something that is built in for people to get started. 2, you can build your own stuff on top of that. Or 3, you can build in some stuff outside, and you have the portability to import. And 4, you have the third-party providers. And in our case, the third-party providers are none other than Marketplace. All the third-party provider softwares or the integrations, solution integrators or software integrators, they're all available through the Marketplace side. Now, for the built-in algorithms, just to give you a better understanding, let me switch over. I'm going to pause it here, and then we'll come back to this slide later. I used don't worry about what is written on the right. This is an easier way of understanding the different algorithms that we've got, right? So on the top left, again, a pointer for you to learn later. There is a YouTube series that is called SageMaker Deep Dive. You could just make a note of it. You could just go to YouTube and search SageMaker Deep Dive. This is taken from that. And there is one 15-minute video that talks about deep dive on built-in algorithms. You can refer that later for more additional details. The reason why I put this is that so that later when you refer, you'll be able to easily relate to what I said now to that of that video. Overwhelming majority of the problems that we have today can be fallen under classification, because most likely, if you're trying to solve a problem with machine learning models, most likely, it could be a classification problem. It could be binary or multi-class classification problem. The other things are all the rest of the stuff. And I would say that as of today, it could be like 70%, 80% of the problems that could be solved under classification. So try to see if you got a problem, will that fall under any of these algorithms that are there into classification. What are algorithms, right? Let's take a step back on that. Algorithms are scientific approach or a mathematical approach to problem solving. Outside of machine learning, let's leave machine learning. In general, algorithms are an approach to problem solving, right? Now, where does this come into picture with regards to machine learning? In machine learning, as we said, we are trying to make a prediction at the end. Each algorithm will solve a type of prediction problem. It all depends on what you choose. Now, if you have a question, how do I choose the algorithm, right? There's no straightforward answer to it. But based on some of my interaction with others, what I have seen is that mostly, right, most likely, what is the type of output that you're expecting in a machine learning problem, that determines your algorithm. What type of output or what type of prediction that I'm expecting at the end, that most likely determines what algorithm I choose. And in most of the cases, what we have seen is that it's an experimental situation. Which algorithm should I choose? The recommendation that we have is that there is one white paper for each of these algorithms. Please try to browse through those white papers, see if that fits, and then go ahead with that algorithm. Try if that works out. This is again experimental, right? If that doesn't fit, then probably try to move. And if you already know what you're trying to solve, let's say I'm trying to solve a computer vision problem, then you don't need any experimentation. You could just go ahead and take the image classification algorithm, right? If it is straightforward, you could just go ahead and pick one of these buckets or one of these algorithms within the buckets. If not, then experimentation is the way. And our approach is go through the white paper, see the fitment, and then go ahead and experiment using that algorithm. Now let's go into each of these algorithms very quickly. First, we saw about classification, right? If time permits, what we'll go through as a SageMaker example today, in the last 5 minutes or so, is a linear learner, right? And then you have XGBoost. XGBoost is the open source implementation of Gradient Boost, pretty much a managed version of that, which is implemented in SageMaker that you could use. And then that's pretty much with classification. If you're talking about computer vision, you have classification and object detection. Image classification, in the previous example, we were talking about that dog image, right? That's pretty much a classification. Image detection is, let's say, if you're using one of these cloud cams that Amazon offers, right? Or the Nest device that you have in front of your home. Typically, you get an alert when there is a person there. So that's object detection. So it's basically detecting an object and then sending an alert. That could be image, video, or anything, right? And then semantic segmentation. How many of us know about semantic segmentation? It's a very interesting one. I'll give a very quick walk. So semantic segmentation is basically used in autonomous cars. So basically, what it does is it's an enhanced version of your image classification and detection, because you need to go at a pixel level in semantic segmentation. In autonomous cars, it need not just detect an object, but it should differentiate objects as well. It needs to know what a stop sign is, as well as it needs to know what an yield sign is. You get what I'm saying? It could be pretty much the same, but it could be two different things, and two different actions could be triggered out of it on an autonomous self-driving car, if you will. Topic modeling. The two algorithms that we have here, latent Dirichlet allocation and neural topic model. Topic modeling is nothing but, let's say, you have a lot of tweets coming in, right? And then you want to classify those tweets based on topics. In those cases, you typically use topic modeling. So basically, you're going to model based on what topic those tweets would fit in. I'm saying tweets, but it could be anything. You could have customer comments or anything that's coming in, and you want to classify it with topics. And then if you're working with text, You have two options within blazing text, supervised or unsupervised. Text is nothing but you have text that is available for you, and then you want to classify the text, you want to work with the doc, and so on. And then from a recommendation perspective, movie recommendations, music recommendations, you have factorization machines. That is the algorithm that's available. Forecasting from a time series forecast, which is for a long period, based on the past data and the present data, I want to forecast what is going to happen in the future. You use deep AR forecasting. There's a very good white paper on that. If you got time, if you want to explore that, please do that. That's an AWS implementation of recommendation. And then anomaly detection, right? I'll try to compare classification versus anomaly, right? In classification, let's say that you have handwritten digits. You want to identify what digit it is, right? It is classification. Is it 1, 2, 3, 4? In that digits, I want to detect if there is an anomaly. I have all digits, but I want to pick only the anomalous ones, like maybe an alphabet is there. In a set of digits or numerals, I want to pick the anomalous one, then you use anomaly detection. And within anomaly, you have random cut forest. Random cut forest is one of the unsupervised algorithms. So if you're getting into this area, most likely it might be a classification problem. So the preference is, it is most easily solved with a supervised algorithm. Could be a XGBoost or linear learner, try that. If not, then probably you can get into the anomaly detection. IP insights, same anomaly detection. The only difference is that the data is IP data. So for example, you want to detect a bad IP from a set of IPs that you've got. So in that case, you'll use IP insights algorithm. And then the other thing which I could talk about is sequence translation. Sequence translation is nothing but you translate one sequence into other, and that sequence could be text or audio. For example, you have a complete sentence in English. You want to translate that into German, right? If you translate word by word, the sentence may not be meaningful, right? The contextual meaning may be lost. So in that case, you could use sequence to sequence. So it takes the complete sequence, translate into other sequence. It's more of understanding what is the context of the whole sentence. That's pretty much with regards to different algorithms. We could go for a long time, but because we're getting on top of the hour, I'll try to stop here. But again, because algorithms are like key in the whole machine learning problem solving procedure, because if you choose the right algorithm, most likely that you're going to be successful. If you choose the wrong algorithm for the problem statement, then it's going to go in a cycle, right? The predictions may be overfitting, underfitting, it may not give a good result, then probably you may have to reevaluate the whole thing. So spend a lot of time in terms of choosing the right algorithm. And as I said earlier, reiterating that, the right way to choose the algorithm is, number one, make sure that you read through the white paper, see which is the right fitment. Number two is experiment. Take that, if you think something fits, go ahead and try that with your problem, see if that works. Heading back to the same slide as we were earlier. Cool, automatic model tuning. What are hyperparameters? Before we get into this, we need to first know what are hyperparameters, right? Before that, we need to know what are parameters. So in creating a model, there are several parameters that you will define. You will give some values to the parameters. Typically, the values to the parameter are determined after the learning process, after the machine learning learns. There are some parameters for which the values are assigned before the learning process. And those parameters are called hyperparameters. Are we good there? Theoretically, broadly, we're good there, right? Now, it is pretty difficult task when it comes to how do I choose the right hyperparameters for my machine learning problem, right? It's typically a cumbersome process or a difficult process. So for that, you have something called as automatic model tuning within SageMaker. that will help you or assist you in choosing the right hyperparameter values. And the way it does is under the covers or under the hood, right? What happens is SageMaker will run several tuning jobs on top of your normal job that you run for your model training. These are all managed jobs, if you will. You will not be doing that. SageMaker automatically runs these jobs. And then we call something as, it's kind of a virtual space that we call hyperparameter space, where it searches for the right value that will yield the optimal solution, right? And there are two types of general searches that happens: random search, Bayesian search. We use Bayesian search within hyperparameter optimization. Random search is, it picks up random values, try to assign it to the hyperparameter, see which works. Bayesian search, on the other hand, it makes some guesses of what parameter it has to assign. And then it will assign those parameters based on those guesses, and then runs multiple training jobs, not just one or two jobs. There are multiple training jobs that are run. And based on that training job, it will see what the results are. And when I say what the results are these results optimal? And once it sees the right fit, then probably it calls this is the right hyperparameter value. And that's how the automatic model tuning happens. But broadly, the takeaway is that you could use automatic model tuning within SageMaker that will help you to assign the right hyperparameter values. Yeah.
So what performance metrics actually selected in order to identify the best model?
Some examples could, I'll take the question in two angles, right? I'll give an example of what is an hyperparameter. Epochs, right? Epoch is an hyperparameter. Epoch is nothing but when you take the data and you have a neural network, right? You pass the whole data forward and backward once, that's one epoch. And how many epochs that you need to assign for a particular model, right? Each model that you train needs to have some kind of a epoch value. That will be determined by this. And to your question, now we know what is a hyperparameter value. Now, what kind of values are considered for it to be a successful one, right? It depends on what output you want to choose. And depending on what output you want and how accurately the model is predicting, based on that, it will select the. It's kind of, I wouldn't call it chicken and egg, but rather it is dependent on each other. Your output accuracy versus the right hyperparameter values are going to be interlinked with each other. I'm sorry, you good? Or?
Yeah, I understand that part. My question is like, what performance metrics that we have considered there in order to actually adjust the epoch size?
We won't consider. You don't have to worry about, as an end user, you don't have to worry about it. The automatic model tuning has a set of parameters. I can point you to the link of the document that will determine, it already has some of the values that it will choose to make sure it is a successful one. That's a standard one. That as an end user, I don't have, that is one of the key benefits of using it, because if you are using it, if you are doing the hyperparameter tuning yourself, then what you're asking is correct, because you need to be worried about what will determine the success of it. But in this case, because the automatic model tuning is happening within SageMaker, it already determines certain success values, and it will go from there. Give me 1 second, I already have some. It is iterative. Under the hood, it is iterative. But from an end user perspective, what you will see at the end of the day, you will have the right parameters assigned to you. Again, if you're not satisfied with it, based on that, then probably you can change that values as well as you move forward. Yeah.
What determines the best model? Piggybacking on his question, so you said under the hood, the tuning decides the best.
I'll bring that website which talks about that just after we move forward. Yeah, I'll make sure that I'll cover this question at the end. So the next slide, this talks about what are all the different instances that are available for you to choose. And again, the range of instances, right, that start from T and it goes all the way up to Z instances. T is the micro or a burstable type of instance, the smallest instance type. And typically for notebook instances, you choose the T instances, and then you will use the AI/ML simulation inference workload on C type of instances with our compute intensive, and then when you're going to training workloads, GPU instances. I'll take a quick stab at this. just on the P3 instances, right, you have an option to attach, P3s are nothing but your GPU instances. Because graphic process unit are very important when it comes to machine learning problem solving, because you're mostly going to interact with machines on image recognition and so on, right? So graphics are important. You also have something called as elastic inference, or EI, which we'll cover later in the section. You could attach an EI to C5 to make it a GPU intensive instance. So you no longer have to be dependent on, oh, I need to run it only on P3 instances. No, you can run the same workload on C5, and then you can attach elastic inference to it to make sure that you attach the GPU capability to it. Finally, inferences. So inferences are nothing but, this is when you have trained the model, you've evaluated the model, you're taking it into production. Now, with regards to SageMaker, these are the options that are available when you have to take it into production. The first one is hosting service, where you can host the model that you have created within SageMaker so that you will expose an API endpoint for your applications to interact. Then you have batch transforms, where you want to run batch transforms instead of just one-off transforms, right? You have large data set and you want to prep the data set, you could use batch transform. And then elastic inference, we spoke about that. We'll cover that in the slide. And Neo is a compiler to optimize your model for the target hardware platform. ARM, Intel, any target platform that you got, and you got to optimize your model, you use SageMaker Neo. Marketplace, optionally, once you created your model, you can publish it into Marketplace. Deep Racer and Deep Lens. I believe yesterday you had a session on Deep Racer. Yep, so I don't have to cover a lot. 118 scale autonomous car that will help you get started with the third segment. We spoke about supervised, unsupervised, and this will talk about reinforcement, which is the learning where you give rewards. Based on the rewards, the model will start performing better. Deep Lens for image recognition, again, it's on the computer vision, where it will help developers to get started with building some intelligent models based on object detection and image classification. Now, this will talk about, we spoke about set of services in hosting, right? This will talk about specifically one by one. The first one is an inference. Within the inference, rather, is the hosting services. Again, what is the benefit of hosting it within SageMaker for your production instance? The key benefit is going to be it's a fully managed service, so that you don't have to worry about scaling it, you don't have to worry about high availability and so on. All you have to do is, hey, I need X number of instances, and this is where my data resides, and SageMaker by itself will take care of providing you with multi-AZ support, as well as giving you sub-second latency, and then it will give you persistent deployments. At the end of the day, what you need is that you just have to expose that API where you have hosted it to your application. So you have an application, and then that application needs to make predictions, right? Basically, you're trying to build that intelligence. So for it to make predictions, you need to have some kind of an API. You have developed a model, hosted it in SageMaker, you will get a single API endpoint that you will interface with your application. Again, this could be application, this could be user. Those endpoints could be directly interfaced there. Batch transform. Before you get into the actual model developing process, you may have to prep your data or cleanse your data. You want to do transform for the entire batch, right? In those cases, you would use batch transform feature within SageMaker. And in this case, you're going to do predictions for entire data set. You're really not looking for some kind of a persistent endpoint, right? Because persistent endpoint is the one that you did it in hosting services. In this case, let's say you're not looking for persistent endpoint. You just want to get predictions of a batch of data, right? One-time predictions. That could be a preparation as well before you get into production. In those cases, you will use batch transform. Elastic inference, very simple. You have a C5 instance or any other instance where you need to attach GPU capability to that instance, right? Instead of using P3. Why should I use it? It's cost effective. I think close to about 70% of cost saving compared to P3 instance to that of the same class C5 instance, and then attaching elastic inference to it. Yeah. Neo. So Neo is again where you train your model once and then you deploy it in multiple locations. When I say multiple locations, those could be any of these target platform, NVIDIA, ARM, Qualcomm, and so on. All you have to do is, once you develop your favorite framework, you then call Neo, and then all Neo will do is that it will compile your model and it will optimize it for running it on the target platform. And when I say optimize it, it's to make sure that you have low latency, high throughput deployment. Those are the two parameters, low latency and high throughput on any of these target platform. And during the compilation process, it will basically take care of optimizing it for that particular target platform. It already has some of the features baked in, which will be used for it to deploy it. Marketplace, once you've created your model, you have an option to publish it in Marketplace, which is going to be available for others to consume. Yep. And then Deep Lens and Deep Racer, as we spoke about Deep Lens, that is going to help you with regards to image recognition. The Deep Lens and Deep Racer both are available on Amazon.com if you want to use it. The only thing that I will say with Deep Racer is that you don't need the physical car. You could get started with it just within your console on the virtual racetrack that you already know. And both of them are primarily to ensure that that is enabling you to get started with image recognition and as well as the reinforcement learning. These are some of our customers that we have today, and you will see some of these use cases later in the session. And then to get started with machine learning, recommendation is there is a site, aws.amazon.com/learning/machine learning. That's where you have a lot of videos, a lot of training material where you could get started. Or you could go into ml.aws. Now, before I wrap up very quickly, I have one question to take on, and before that, I will get into a brief of the SageMaker console so that you get a hands-on in terms of where to search for what. So this is, all you have to do is, once you get into the console, I'm going to log into the console. Once you get into the console, all you do is type in SageMaker, or in this case, I already have it, so I'm going to open it. And within SageMaker, what you see is these are the sections that we spoke today. Yep. Ground truth, notebook, training, inference, marketplace, right? Each of these sections will get you to that particular component within SageMaker. Now, I have a notebook instance that is already running, which is a linear learner algorithm that I'm going to choose. And on the left side is what you will have all your algorithms, training, and hyperparameter tuning jobs. So let me get into one of the tuning jobs that I already ran. This is a pretty old job that already ran. And if you see the training job configuration, this is where you will see what is all being trained and what is being validated. And also there is output data that is being put in terms of the data configuration in here. And then this also talks about what is the job configuration in terms of are we using the Bayesian strategy or so on. And then the parameters, right? This is where we were talking about what are all the parameters that we are going to use. So these parameters, right? The ETA, which is going to be continuous, and there is a value, and then there is an objective that we are going to achieve out of this, and then there's also going to be a max depth, which is an integer. These are the final outcome of the hyperparameter values. And then when you get into the inferences, right? This is the last section that we spoke about, where I was talking about you will have an endpoint that will be available for you, right? In this case, there is no endpoint, but typically when you run your training job, and after you run your training job, when you do a deployment, there'll be an endpoint that will be available here. This will be your endpoint that you will interface with your application to make predictions. That is after you deploy it into production. And then let's get into the notebook instance. This is the key component that I wanted to talk about. So the linear learner, which I've started, when you open your Jupyter notebook instance, right? So let's get this one. So as I was mentioning earlier, this is where your kernel is, and then you have the options to interact with the kernel here. And then within your SageMaker itself, right, under Jupyter Notebooks, this is where you will open the Python Jupyter Notebook. But I was also referring to SageMaker examples, right? When you log in into Jupyter, this is where you will find all the SageMaker examples that I was talking about. So this is where you can get started. All you have to do is to go ahead and start using it. Whichever the ones that you think you want to choose one, please go ahead and get started. I would say Linear Learner is a good option for you to get started, or at least to get an intro into it. So I would prefer taking into Linear Learner. So here, what we are doing is, in Linear Learner, we are doing binary prediction in terms of handwritten digits. I've given like a lot of handwritten digits, and the model is basically predicting if the given digit is a 0 or no. It is not predicting what the numerals are, like is it a 1, 2, 3, it's not doing that. It is only saying if it is a 0 or no. So a good use case would be, let's say I want to focus on customer satisfaction survey, where customers have given me a 0. I want to focus only on those customers, right? So in that case, let's say this organization is giving pamphlets to users where they're filling it in hand, and then you get that as a response. So you have like hundreds or thousands of pamphlets back, which are marked on a scale of 1 to 9. And then you want to identify only zeros. I'm just calling out a random example, right? So in that case, you could use this algorithm, and basically it is trying to figure out, so this is a 3, right? This is where you're going to do the data inspection. The first process after you say, hey, this is where my S3 bucket is, and then I'm going to initially do an inspection to see what kind of a digit that I'm getting. And then you do a data conversion, upload the training data. This data is going to be whatever data that I've already trained based on the input handwritten digit. This is coming from MNest. And then finally, here from an estimator perspective, this is the same example that you saw on the slide, where you're just calling, I'm going to call this instance type, and then I need just one instance where I need to train the model with the data that I've got. And then finally, after I have done this, go ahead and deploy this on an M4X large. One key aspect that I would like to call out is that there are 3 instances that we are talking about here. Notebook instance, which could run on T2, because it is just the Jupyter notebook. No model training or anything is running. But on this notebook, what do you see here? This notebook is calling 2 other instances. One for training your data, which is the C class instance, and one for after you have trained the data, after you have trained your model rather, you will move that model into production, that is the hosting. And that is what is called here as M4. M4 instance. And then you will validate the model for the use. And then finally, the predictions are here. This is where the actual predictions are run out. And just to give you a brief on the predictions, all it is doing is on the top that you see, it is just predicting. It is just predicting if it is a 0 or no. So 1 is true, right? And give me 1 second, I'll wrap it up. 1 is true and 0 is false. So if it is a 0, then it should be listed under 1. Yeah? 1 is true and 0 is false. We'll go with that methodology. Because we are trying to predict a 0 or no, right? If it is not a 0, then it's false, which will fall under 0. A 0 is not a 0, yeah? You get that? So the actuals, what you see there are the actual numbers. And the prediction, what you see there is what my model has predicted. So the zeros, which are not zeros, right? The top one that you see here, this one, right? This is my prediction. It is not a 0, it is a 0. So I have predicted 8, 9, 7, 3 as not zeros, but actually they are not zeros. This is the actual, right? So this is the correct prediction that I made. And similarly, the 1 and 1 which matches here, this is also a correct prediction, which I've said it is a 0 and it is actually a 0. And these are the false positives. You get that? So that's what basically we're trying to predict out of it and finally wrap it up. Yeah, go ahead.
The model that you deploy to another F4 instance,
Uh-huh.
so can we save the model out rather than?
You could.
So is this model optimized to run only in AWS cloud, or it can run anywhere?
It can run anywhere. It can. When you say can it run anywhere, from a portability perspective, you can port it very easily into SageMaker or take it out of SageMaker as well. And you can interact as well. That is one side of the question. The other side is.
Can you repeat the question for the live stream?
Oh, sure. He wanted to repeat the question. So the question is, can we port it to and back of SageMaker? The answer is yes. You can run the model outside. You can run the model in. And again, from a notebook instance perspective, that is also something you can run outside. The same notebook instance, you don't have to run it on SageMaker. You could run it outside, and then you could portably get that notebook instance into SageMaker as well. Right. So I think we're top of the hour. Before he comes in, let me show that question of hyperparameter optimization, right? SageMaker automatic. So the question was, what are the success criteria to select the right hyperparameter values? So if you get into perform the automatic model tuning under SageMaker, you will see the metrics and what are all the ranges of the hyperparameters, as well as I'll take define the hyperparameter ranges. So in this case, all you are saying is that I'm going to define a range of hyperparameters which has to select the value from that range. And then it is going to run the parameter values. And then finally, once it is going to run the parameter values, let's say I'm giving an example. I'm going to take the same example. I want to predict the model to be a 0 or 1, right? The same example. And you see the lot of false positives there, right? That can be taken as an example for your hyperparameter. The lesser the false positive becomes, the more accurate your hyperparameter values are. Does that make sense? So based on that output, it is going to evaluate the hyperparameters. But that is not only going to be the defining parameter there. It could be because of the hyperparameter. It could be because of your model needs to learn better also. Because we have something called as overfitting and underfitting. So you got to make sure the model is more generic and it is not solving a particular use case. So you need to understand that as well. Again, for you to refer later, if you get into this documentation that talks about define hyperparameter ranges, here you can read more about what is going to define the success criteria for hyperparameters. Cool. So we already 5 minutes on top of the hour. I hope that I've given you enough material just to get started so that you can go ahead and refer, and it will also be helpful for the session later today. Thanks a lot for your patience. Wishing you all the very best. Thanks, guys.